Hi everyone, welcome to this new lecture of hydraulic machines. In this lecture, we'll discuss another one topic regarding minimum speed for starting a centrifugal pump. So in our previous lecture, already have discussed regarding the working principle of centrifugal pump and head and efficiency, and also we have solved some problems. But here we'll see what is the minimum speed required for starting a centrifugal pump. So to understand this concept, we need to clear about the working of centrifugal pump. Just I'll give a brief idea about the centrifugal pump, how it is working. So suppose this is our centrifugal pump, and here we have a suction pipe will be there. Just I'm giving a line only, not in the pipe case. And here we have the water storage, and that is called actually sump. And this is our pump is there. In that pump we have like many parts are involved in this, and this is our delivery pipe. So here let me write in the short ways, suction pipe, and this is delivery pipe, and this is our pump. As I told you, like here shaft will be there, impeller is there, vanes are involved, so many things are there. So what is the work of this? Like when you start the motor, that motor will be connected to the shaft, and when motor started, that shaft is going to rotate. Then in that shaft there will be a impeller. So impeller is fitted on the shaft. So impeller also started rotating. When it started rotating, there will be a pressure difference between this impeller and the water which is present here. Okay. So here vacuum pressure will be created, so that here high pressure will be there, P atmospheric here. So the water started flowing from this level to here. So that means there is a pressure difference created here. Anyway, by that here it is entering and it is going to out. Okay, that's why it is delivery pipe. This is suction pipe. Now the distance from here, the distance from the center point of this pump to this sump level, that is called HS, that is called suction head. That is called suction head. And the distance from here up to this level, that is called delivery head. Okay, that is called delivery head, which is indicated by HD, and this is HS. Okay, and the total distance or total head is nothing but the, you can say that total head, that is indicated by H. Okay, that is indicated by H, and also we can write H equal to HD plus HS. Okay, now that is also sometimes it's called a static head, but we have a target of like the water supposed to be flows from this level to some level of this one, total level. So that is the total height is given, but due to some losses, the water is not able to supply from this level to the targeted level. Suppose it's only flows up to a level of this. Okay, and that level we need to mark it as a, this level we can give it HM, and that is nothing but manometric head. This is called manometric head. Total head is this much, but due to some region, what is the region in that? That is called actually losses of head. This is called losses of head, and that losses of head is of many regions are there. Either it may be minor losses or major losses, because when the water is flowing in this, when it is entering to this pipe, it may be some losses will be there. Okay, and when it is existing from here, also losses may be considered, that is minor loss. When the pipe is in bend, and whether there is a impeller is rotating, okay, the impeller rotating and the casing is there outer, so between that also losses will be there. When the water is flowing through the pipe, major losses will be there. So by considering all these things, we can say there is few losses will be there, that is called loss of head. So what is our expectation was there, up to that it won't flows up to a next level, that is called manometric head. Okay, HM. So this HM is required here. See, what is the minimum speed required for starting the centrifugal pump? So if the pressure rise, okay, if the pressure rise in the impeller where it is, here is the impeller. Okay, if the pressure rise, we can say if the pressure rise in the impeller, it should be actually impeller, it should be more, or it should be greater than or equal to, we can say, the pressure rise in the impeller, it should be greater than the manometric head, Otherwise, if this is the condition, then only the centrifugal pump is is going to work, or it can work, or it can deliver the water. That means for centrifugal pump, if this is the condition, then centrifugal pump is working, or it is delivering the water. Okay. If not, if the pressure rise of impeller is less than this one, then the centrifugal pump is not going to discharge any kind of water. Okay. Even though impeller is rotating, if this condition need to satisfy to deliver the water. Okay. If it is not, then it won't work. Very simple. Okay. Now, what is the head due to pressure rise in the impeller? That is the next question. So next one I'll write the head due to pressure rise, due to the pressure rise in impeller. What is the head due to pressure rise in the impeller? That is actually, we can write this is delta H, or we can write this is delta P. What is the pressure rise or pressure difference, how much is there? So this one actually we can write this is U2 square by 2G minus U1 square by 2G. Okay. This is the velocity head at the outlet condition, velocity head at the inlet condition. Very simple. Okay. And these things you can identify if you see the velocity triangle there, at least you can identify these values. Okay. So this is about the head due to the pressure rise in the impeller. This one we identified. Now the thing is, the flow of water, okay, the flow of water only valid, or it is going to flow only when this condition, like this is the rise, is more than this one. So what I can write here on behalf of this, we can write now U2 square by 2G minus U1 square by 2G, it should be greater than or equal to HF. This is as per our concept, as per our definition, it need to satisfy this. Okay. This is minimum required, like if the pressure rise in impeller is more than this one, then only it will be work. The centrifugal pump is going to work. Okay. Now for the minimum speed, let me write another one. For the minimum speed, which is required to start the centrifugal pump, or for the minimum speed, what we must have, we should have what, at least it should be equal. Whether it is not more than that, at least it should be equal. That means what I can write, this is U2 square by 2G minus U1 square by 2G is equal to HF. That is the minimum. Here see, here two conditions are there. One is greater than, another one is equal. At least minimum equal in the sense, that means this one, this value equal to this value should be there. Okay. Now this one we can give, this one let's give equation number 1. Okay. And this is not required. This one we can give equation number 2. Okay. Now this is one terminology. Okay. Now in the manometric efficiency, we have seen, if you remember that manometric efficiency, what we have discussed in the previous lecture. So the manometric efficiency is calculated, or it is identified. The formula was given GHM by VW2 U2. VW2 by U2. Actually, it was HM by VW2 U2 by G. The G was taken here. That's why we got the value of this. Now, if I write this equation, okay, in terms of manometric efficiency, so we can write HM equal to, what I can write, this is manometric efficiency into, I can write this is VW2 U2 by G. Okay, I can write in this way. So why I have taken this manometric efficiency here? Because the HM part is involved in this. Okay, that's why I have taken this manometric efficiency here. Now, what I'll do here, I'll take this equation and I'll put in this above equation. Like I'll take this value of HM and I'll put in the above equation. Then what I'm going to get here, like it will be U2 square by 2G minus U1 square by 2G equal to, we can write in this way, like manometric efficiency into, this is what is given, we can write Bw2 U2 by G. And this one we can give equation number, suppose 3. Okay. Now here again, see U2, these are the U1, U2, these are the tangential velocity. Previously I told, actually this is tangential velocity which is used in the velocity triangle. Okay. Now I know this already, we have derived this value. So U1 equal to, we know the formula, that is pi d1 n by 60, and U2 equal to similarly pi d2 n by 60. So d is the diameter, n is the speed, and pi value is the constant. Here this is inner diameter, this is outer diameter. Okay, and these are the tangential velocity at inlet and outlet conditions. Now these values of U1 equal to this one and this one, we can put in this equation. Let's put in the equation of 3. Then what I can write, this is pi d2 n by 60 whole square. Then we can write, this is 1 by 2g is there, let me write 1 by 2g, and this one also we can write, this is pi d1 n by 60, again this is whole square into 1 by 2g, and this is equal to our manometric efficiency into, we can write, this is Vw2 again U2 is there, U2 value again you can write here pi d2n V2 by g, so g value into 60. Okay. Now this is the equation what we got, somehow critical is there. Okay, somehow critical equation we got. So what I'll do here, I'll divide pi n by g60, because everywhere if you see g60, g into 60, g into 60, g into 60 is there. Okay, and pi n, if you see pi n and pi n, everywhere pi n by g60 it is there. So what I'll do here, dividing the value, dividing by pi n, okay, pi n only, okay, pi n by g into 60, dividing the value of, dividing the equation of pi n by g60 in the above equation, then what we can get here, we can get from this, like if you divide, what will be cancelled, this will be cancelled and g will be cancelled. So what will be there, only like d square, sorry, pi n, okay, pi n cancel. After cancelling, what will get here, square is there, correct? So 1 will be cancelled, not both, so at least 1 pi will be there. So what we can write, this is pi n d2, pi n d2. Again here also we'll have like 160 cancel, correct? 1 more 60 will be there, so 60 into 2, that will be 120. Okay, now g is not there, g we have cancelled, this minus, similarly here also we'll get the same thing. Okay, d we have not cancelled, only pi n cancelled, so here d2 square will be there. Okay, and here also same thing, pi n, and this is d1 square by 120, and in the right hand side we'll get the value of manometric efficiency, and here we can cancel all the things, like pi cancel, n cancel, g 60g also cancel, then only manometric efficiency along with this Vw2 into d2. Okay, this is the value. Now here just it is in the final stage, what I'll do, I'll take a common of pi n by 120 from this left hand side equation. So what will be there, this will be only like d2 square minus d1 square, and in the right hand side as usual we can write eta efficiency, that manometric efficiency into Vw2 into d2. Okay, now what is our requirement, we need to find out the minimum speed. So minimum speed is nothing but n, so we need to convert all this equation in terms of n. So I'll take only n one side, remaining value I'll keep it to the other side. So that will be here 120 is the denominator, so that if I take in the right hand side, so it will come like 120 multiply eta, like manometric efficiency, into VW2 into D2 divided by what was the remaining terms are there here, like pi into you can write in the bracket, this is D2 square minus D1 square, bracket close. Okay, this is our answer, required answer for this. Now this equation actually it will gives us the minimum starting speed of the centrifugal pump. That means at least minimum this much speed required to start the pump, and this one we have identified from the value. Okay, yeah, so I can just give a brief about this, like where we have started. This one, this is the condition what we have taken, correct? So this condition need to be satisfied, okay? But this is maximum, here greater than also there and equal to also there. Now to satisfy that one, we have taken at least minimum, the speed should be this much, minimum speed should be this much. So from there we have started and we found here up to the last one, this minimum speed required to start a centrifugal pump. In between, like manometric efficiency also we have I've taken one more formula involved here. So these things at least we need to remember, and very many things is simple. I hope you understand this derivation. If you're having any kind of doubt and query regarding this, you can give a comment on the comment box. Again, even also this value tangential velocity, these things actually I have not derived in this lecture, but previously already told you. I hope you understand. Yeah, thank you.